with some partners to put this together for everyone here today. So what we're going to talk about is we're going to talk about managing residue. And there's been a lot of research done on managing residue, especially at the University of Illinois. And, I hope what we get across here this morning is the value that is brought to the farm and the crops that we plant on the farm when we manage residue in the field. And so as I think about it, and I think many of us should think about it, is our planting season really starts at harvest. And this slide shows a field many of you may have seen, but I think it's really impactful, of a field up by Paulina, Iowa, where after harvest residue release was applied in some strips, and it's very evident after 60 days after application of what this product looks like in the field. You can see the center strip was not applied, and you can see the breakdown of the residue where it was applied. But from a seedsman perspective, what managing residue to us, especially with residue release, is creating that good seed to soil contact. You're getting that better stand, possibility of reducing tillage passes, increasing nutrients available, and the product comes at a real low use rate, tank mix compatible with a lot of different things, and it speeds that breakdown of nutrient release. So it's preparing us for a good seed bed in the spring, a good even emergence, and a real good final stand, which all correlates to yield. So today, we're really fortunate to have two distinguished individuals from the University of Illinois to talk to us about residue management. Dr. Fred Below, professor of crop sciences at the College of Ag, Consumer and Environmental Sciences. Dr. Below is world renowned. He's
renowned.
Yeah, renowned.
Sorry about that. Speaker. That's my fault.
Well, he's probably renowned. He's published 100 papers. I'm sure that many of you have heard him speak about the 7 wonders of corn. I've done a lot of work with soybeans as well. And then also Dr. Connor Sybil has joined us working with Dr. Fred Below and is going to speak to us here today. So with that, Dr. Below and Dr. Connor, thank you for joining us this morning, and I will turn the slide deck over to you.
You guys want to share your screen? There it comes. Perfect.
Hey, Paul, thanks for that introduction. Thanks for everybody for joining us here this morning. I'm Fred Below. You're going to start with me. Dr. Connor Sybil's going to join. So I'm the old guy, been around for a long time, got some street smarts, don't actually know anything or how to do anything. And Dr. Sybil recently got his PhD with me. He's sort of the leading expert on biologicals in row crop production. So, today's education. I appreciate you doing it, but education is hard. It's like exercise. So it's gonna, we're gonna try and educate you, and the reason we're doing that is knowledge is power, and that helps you position your products. So we're only going to talk about corn today. We're going to talk about corn yield, factors that affect corn yield. In fact, the 7 wonders will be touched on. We're going to tell you what's coming and why it involves residue and biologicals. So Paul said we were going to talk about residue. We're also going to talk about biologicals, because there's some biologicals that can help you control residue. So, I like to ask a bunch of questions, and I'm going to start off with a question. And the question is, what are those management factors that have the biggest impact on corn yield each year? Guess what? That's my so-called 7 wonders of the corn yield world. That's the top 7 list. of those factors that each year can have a positive. Well, and bad news is some of them are negative under the wrong conditions, impact on crop yield. And so what I'm going to be able to do, I can give each factor an average value. I've worked on corn long enough. I'm going to use this as a prelude to today's discussion. Now, before you get into the factors that affect corn yield, there are some crucial prerequisites. This is what I like to call the table stakes. There are things that don't necessarily add yield or don't have to be done every year. I can't tell you, how important soil structure is. Don't compact the soil. Boy, the tile drainage can make a big difference. But once it's done, it's done. Weeds, pests, diseases don't add yield. All got to be under control. I mean, if you got a disease or a weed pressure, well, some of these other managements aren't going to help you. And I'm going to talk about this one a little bit. You know how we base our soil fertility based on a soil test. So sometimes we can adjust the pH. I'm going to talk a little bit about soil tests. I'm going to tell you there needs to be an adequate base level. So then after that, and I don't have time to do this, what are the 7 factors that impact corn yield each year? I could talk about each one of these for an hour. You probably already know some of them. Obviously, the big factor that has the impact is the one that's least under your control, the weather, all kinds of weather possibilities. The second factor, that's nitrogen, how you manage nitrogen fertilizer. Now, here's a nuance that we have to keep in mind with all these wonders. They're all going to be interact with each other. And as a general rule, the higher you are on this list, the more control you're going to exert over those wonders below you. I mean, think about nitrogen fertilizer management. Every single thing about it is influenced by weather. Number 3, this is one in your game, hybrid. I mean, this is the most important decision that growers make every year for what hybrid they pick. Number 4, previous crop. We're where we grow corn and soybean. So if corn was a previous crop, there's a yield penalty. I'm going to put cover crops in previous crop too. You're going to see, we're going to talk about that. These are ones we really have to manage with some of the technologies that you have. Number 5, really important and up and coming, plant population. How many seed you plant. This one's pretty important to you if you're a seed dealer. Number 6 is tillage or no tillage. Think about whether you till or not. All about trying to control one of the wonders above you. And number 7 is a catch-all that we're going to spend a little time talking about, and that is biologicals. So here's how the story goes. If you've optimized the value of, if you have good weather and you've optimized the value of the other 6 wonders, you should be able to grow 260 bushels. By gosh, that's routine in our research trials nowadays. And by the same token, if one of these is non-optimized, I'll guarantee you're going to grow less than that. So here's the key. How are you going to use this concept to grow more than 260 bushels? Well, remember, I told you all 7 of these things interacted with each other. Boy, that's what makes crop production such a challenge. I mean, think if you had 7 kids, how many fights and alliances they could get into. So these 7 things are interacting with each other. And so to grow more than 260 bushels, you have to optimize each of these and their positive interactions. You need to get some of them to work in a synergy. Now, I have a question for you. This is related to these wonders. And the question is, which one can you use multiple applications of and get multiple increases in yield? And that is the biologicals. Dr. Sybil is going to talk to us a little bit more about biologicals, but this is a really versatile class, and it's the only one of the wonders you could use more than once and potentially get more than one 10-bushel increase in yield. A lot of different ways you can use biologicals. I think you can put them on your seed. A lot of new innovations coming there. You could put them in furrow, usually with the starter. You can put them on vegetative stages, usually with post-emergence. You can put them on during reproductive with the fungicide or the insecticide, and you can even coat some of them on dry fertilizers. A lot of versatility. Here's one of the things about all of these biologicals. When you put them on this way, they're getting a free application ride. So you're not actually having to pay for the cost of the application, and that really makes the ROI on their use more attractive. Now, another way you could use these and this is what we're going to talk about here at depth today, is you can put them on crop residues. So I have a question for you related to residue. You know, is residue your friend or is it a foe? You know, when I talk about residue, I'm talking about what's left over after we harvest. Some people call that trash or litter. The scientific term is stover. I don't think any of those terms are effective for the value that comes in that product. So I'm going to call it crop residue. Is it your friend or is it a foe? Well, let's think on the friend side. Residue does a lot of things that are beneficial for corn production. First of all, it's the only way to build soil organic matter. Once you got that residue, it can really prevent soil erosion. I'm going to show you it's food for microorganisms, and it's a huge source, as we'll show you, of potential tapped mineral nutrients. So in some cases, residue is your friend. Now, here's another question related to the 7 wonders. And which of the 7 wonders of the corn yield are directly related to crop residue? Well, the answer is all of them. Some of them more related than others, but every one of the factors that affects corn yield has an impact on residue. Now, a couple of them have even larger impacts, and one of them that I'm going to highlight today, is previous crop. Now, by previous crop, I mean what was the crop grown before corn? And I think you know if soybean was the crop grown before corn, well, the corn yields 25 bushels more. But if corn, or in some cases cover crop, was the previous crop to corn, then there's a yield penalty, on average 25 bushels, known as the continuous corn yield penalty. Now, I have a question for you related to the continuous corn yield penalty. And the question is, does it go away with time? You know, in other words, if I stick with continuous corn, does that penalty go away with time? I know a lot of people believe this. That's not what we see in our research. I'm going to show you 2 fields that progress 7 years into continuous corn, show you the size of the continuous corn yield penalty. So these are 2 fields. They're going into continuous corn. What I want you to notice is with years in continuous corn, the yield penalty doesn't get less, it gets worse. On average, a continuous corn yield penalty is about 25 bushels. But you notice it doesn't get better with time, it gets worse. Why? Why does the continuous corn yield penalty get worse with time? And that is because the cause of the continuous corn yield penalty is the residue. Got a picture here showing you, right, our plot, 7 years of continuous corn versus a corn soybean rotation. Look at all this residue after 7 years of continuous corn. And this is under tilled situations. I mean, notice in this picture, there's a little nitrogen deficiency here, and that's because this residue is immobilizing nitrogen. Sometimes that residue also can release allele chemicals that can interfere with the growth of the plant. So the penalty of continuous corn is due to the residue. If you're growing continuous corn, it's all about managing the residue. In fact, Dr. Sybil's going to show you one of our case studies where biologicals can really help in managing that continuous corn yield penalty. Now, another one that has an obvious impact on residue is tillage. I don't have to tell you that conservation tillage is one of the best ways to build soil organic matter, prevent soil erosion. But sometimes, well, if it's doing this, it's your friend. But sometimes it can be a foe. If you have too much residue, it clogs up the planter. So this is where residue has to be managed. Now, the question is, how much residue do you have? And what's its mineral nutrient value? So through the wonders of math, I can tell you that for every bushel of corn that you harvest, you have 44 pounds of dry residue. I like to think of corn as the yield, but it's always that residue. Residue is sort of nature's biological because it's that food source for microorganisms. 44 pounds of residue per bushel. If you look at the amount then on an area basis for different yield levels, that gets pretty substantial. 200 pounds, 200 bushels per acre yield, that's 4.5 tons of residue. I mean, if you can get 300 bushels per acre, you have almost 7 tons of residue. Now, that's the amount to feed the soil microbes to build the soil organic matter Then the other question is, what's the nutritional value of that residue? So I show you some values of NP and K, pounds per ton. This comes out of some literature we published. A lot of variation you see in the literature on these values. I think it depends on when the residue was harvested and how it was harvested. But this represents our scientific research of it. And what you can see is a fair amount of nutrition that's locked into that residue. This is the amount per ton. If you multiply this by the amount of residue that you have from different yield levels of corn, now you can see that the amount of nutrients locked in that residue is fairly substantial. I mean, look at how much NP and K you have in 200 bushel corn. You have up to 300 bushel corn. Geez, it gets even greater. Now, here's another key aspect about nutrients when they're in residue. If that nutrient is a cation, like potassium, the nutritional value of cations, the amount in the residue is up to 3 times higher than it would be if you applied that same amount of nutrient as a chemical fertilizer. So in other words, cations in residue have a 3x nutritional value. Why is that? Probably because when that residue releases that nutrient, it comes along with biological activity that keeps that nutrient available and prevents it from being as fixed in the soil. So this 23 pounds per ton value of potassium is actually worth almost 3 times that value as a fertilizer. Now, obviously, what we need to do is we need to manage that residue. Now, the key to managing residue is to synchronize, enhance the degradation, to synchronize the release with the subsequent crop demand. How are we going to do this? Well, we're going to show you in our case study for corn, but this applies to any residue. The first way to get the full value of residue is to chop it into smaller pieces. I mean, I cut my food up. If you chop it into smaller pieces, the microorganisms can have at it. And so here's an example of one way we do it. We have a chopping corn head versus a non-chopping corn head. We have smaller pieces. The other thing you could do after you chop it up is treat it with a biological. Residue release would be a key example to enhance that breakdown, and then better yet, chop and treat it. One more factor that I'm going to mention to you before I turn it over to Dr. Sybil, and this is a question, and this is heavily related to how and why we got to manage residue and why biologicals are going to be an important part of crop management moving forward. So I want to know which management factor in corn production has changed the most in the last 50 years. And I'm going to make this a multiple choice question. So which one of these factors has changed the most in the last 50 years? Has it been the use of foliar fungicides, the yield of modern hybrids, the rate of nitrogen, the population of plants, or the use of biologicals? 4 of these things have changed in the last 50 years. Obviously, biologicals is on the rise, but it's a fairly new endeavor. Foliar fungicides, it's probably about a 25-year endeavor. Rate of nitrogen fertilizer applied, actually, that's been the same for about the last 50 years. Yield potential of modern hybrids has no doubt gone up, but the main factor that's changed over the last 50 years is the plant population, the number of plants per unit area. So I'm going to show this to you. I'll show you the average corn yield in the US over the last 55 years, and then superimposed here is the average planting population over that same time period. So what we're showing you in the orange triangles, that's the average yield of corn in the US in the last 55 years. And you'll notice it goes up and down depending on that year's weather. But on average, it goes up about 2 bushels per acre per year. Now, associated with that increase in yield, there's been a linear increase in the number of plants planted. That's the blue line. Plant population has continued to increase every year. Why? Well, one of the reasons, because plant population is a component of corn yield. You can make corn yield into a math equation by multiplying the 3 yield components together. So corn yield is the product function of how many plants you have per acre, I know it's actually years, but you have to start with the plants first. How many kernels you have on each plant, and the weight of each individual kernel. And an increase or decrease in any one of these can be responsible for an increase or decrease in yield. And these act at different times in the growth and the life of the plant. I mean, look, you have to increase at least one of these in order to increase yield. Now, which one does the grower have the most control over? Well, it's plants per acre. And because of that, if you look at how plants per acre change, it increases a little under 400 plants per acre per year. This cannot change. This is the biggest factor that's driving corn yield, the number of plants. Now, I have a question related to you about plant population. And as they increase the population of plants, what happens to the size of each plant's root system? Well, the answer is it gets smaller. I have photographic evidence, because this is a graduate student's favorite task, digging up and washing roots. I mean, talk about a good time. Look at this sweet root washing setup. We dug the roots out of the field, we soaked them, we're pressure washing them, we're gonna scan them and weigh them. And I mean, look at the sheer happiness on these students' faces as they're digging up and washing these roots. I mean, there's Dr. Sybil there, just thoroughly enjoying the process. And the photographic evidence shows that the root system gets distinctly smaller as you increase the density of plants. You can see it in the picture. Now, in order to quantify this, we actually weighed these roots. Here we show you the weight of the roots in grams, and notice the weight goes down as you increase the population. In fact, it goes down a linear 2.5% for every 1,000 plant increase in plant population. So every time you plant 1,000 more plants, each plant has a 2.5% smaller root system. Do you think this is important? I mean, do you think having a smaller root system doesn't put these plants under the potential for more stress, whether that's weather stress or nutrient stress? I mean, let's think about the roots. That's where plants take up nutrients. So I have another question for you, one last question related to roots. And this question is, when were salt test values calibrated to corn yields? What year? So salt test values were calibrated to corn yields in the 60s and early 70s. And by the way, we still use the same values today, 60s and early 70s. Anything different about how we farmed in the 60s and early 70s? Well, we grew a lot less plants. Right here, this is when salt test value was calibrated to corn yield. I mean, think of the size of the root system that you had then. Now, I'm not saying soil test isn't important. It is. You got a low one, you better do something about it. But I'm telling you, we're planting more plants with smaller roots. We're relying on old soil test values. We're going to have to do something else to make sure that that plant has adequate plant nutrition. So the question is, how can we ensure that the plant has adequate plant nutrition? It's not under stress when we have more plants grown that have smaller root system. And I put a question mark here. The answer is biologicals. That's the key to some of the technologies that are becoming available and that Dr. Sybil is going to speak to you about. Now, I'll make 3 quick takeaways before I turn it over to him. I told you about the 7 wonders very quickly. I said they all interact with each other, and every one of them impacts residue accumulation. Some of them more than others, but they all involve residue. Residue is important because it's nature's biological, filled with a lot of nutrient goodness, food for microorganisms, but it has to be managed. And then maybe biologicals are the way to relieve plant stress to ensure adequate plant nutrition as we grow higher plant populations and plants have smaller root systems. So I hope you're adding questions for us in the chat that I'll help get to you later. In the meantime, I'm going to turn it over to Dr. Sybil, who's going to really trying to educate you on biologicals. Dr. Sybil.
Thank you, Dr. Bilo. I think it's a great setup for where we're going to transition next. I'm a big fan of residue. I spent a couple of years working on residue management in tandem with this biological market space. And I have to give full credit to Dr. Bilo. When he first threw out that term that residue is nature's biological, I was a little upset because I really wished I'd thought of that first. Because it really is. There's so much value in the residue and what that can do for our systems if we can manage it. Dr. Bilo very clearly said Residue is a friend or a foe. He showed some good examples of how that can be on either end. And the other thing is we're increasing plant populations. That root system gets smaller, but as Dr. Bilo mentioned, we're fertilizing the same. So it's all about making sure we continue to manage nutrition to feed more plants to then get those higher yield levels. And by the way, when we're planting more plants per acre, we're also getting more above ground biomass, more residue to deal with. So if we're changing that mentality and how we're pushing our systems, but the fertility management hasn't quite changed. What's next? What can we do in our next input into the system to really get the value out of our cropping systems residue and get some ROI and higher yields? That's where we step into these next innovations in row crop production. And if I'm going to oversimplify it, the term we've heard a lot today is biologicals. Now, Dr. Bilo has used the term biologicals all morning, but I gotta be honest, I don't think he's actually said what they are, because that's what I'm going to do. Because there's a lot of questions behind this whole space. We call it the wild west of ag, right? Seems like probably new biologicals are always popping up on the market, but there's a reason for this, because there is a value and they are next step input. So what are biologicals? We start by categorizing this into three major bins. The first one is the plant growth regulators. These aren't necessarily new, they've been around. There's products out there. In summary, these are your plant hormone products, right? So they've got the auxins, the cytokinins, the gibberellic acids. That's the active ingredients here, plant hormone mimics. Then you have these beneficial microbes and the biostimulants. And when we look at these three categories, we do start to separate them out, because there is a difference when we start to put the perspective of that PGR versus the beneficial microbes and biostimulants together. And I already kind of alluded to that, right? In general, any product that has your classic plant hormone is a plant growth regulator. So if that jug says bigger roots, bigger shoots, PGR. Everything else is what falls into this biostimulants or biologicals space. They all take unique labeling approaches, right? This is one of the challenges that the industry is facing currently, but I'm happy to say there is some work being towards figuring this out. But I've seen a lot of different products come at me with it's a fertilizer additive, right? But this one's a soil amendment. Inoculant's a term I think we're all familiar with in the soybean space, but there's some inoculants now in the corn space, right? That's changing a lot. Or we're going to inoculate the residues to decompose those more efficiently. You got liquid fertilizer. I've seen that on a jug. Is it 0.0 potassium applied at half a gallon of the acre. I'm pretty sure it was the other stuff in the jug, right? But that's getting the crop response rather than a 0.5% potassium, and then adjuvant, right? So there's a lot of confusion in the space. So we're going to kind of start by summarizing this down and just kind of getting down to the nitty gritty of what these products really are at the end of the day and why they can be a useful next step input. So we start with the beneficial microbes and the biostimulants because the PGR is just pretty well set defined. We're not talking the hormone product, we're talking the other stuff. If we're to oversimplify this really to a high level view, right? It's the living versus the dead. That's where we first can kind of split these two product categories from each other. And then more specifically, it's the microbes and often the products they produce. A lot of these biostimulants that we work with are actually metabolite-based products from living microbes through the fermentation process that they're able to collect. So there's a lot of synergy here and connection between the products, but they are different because the microbes themselves are alive and the biostimulants are not. So then the real question is, what are biologicals? Because, you know, we use that term, and then I said it's plant growth regulators, beneficial microbes, biostimulants, but that still doesn't say, you know, with those terminology, what can I actually take to the farm and what's it going to do? And that's where we're going next. And so this is what I have on the screen coming up is the biological subcategories, the 7 categories that we see most commonly today coming across the table with these new products. And these first 3 here are what we'll call those beneficial microbes. So these are the living microbes. And these bottom 4 are the biostimulants. And in the interest of time, we're going to go through these briefly one by one and kind of talk, you know, this is what the type of product is. This is what it's bringing to the farm. So you can think about how to use it. And like I said, these are the 7 most common today, but I think there's a lot of new ones up and coming that's going to change this space. Starting with the nitrogen fixing bacteria, this has caused a lot of, I think, buzz in the area, right? A lot of products out there promoting a new nitrogen source for corn. That's kind of exactly what this is. It's something we're familiar with soybean and legume crops, right? Those nodules, rhizobium on the root, soybean plant does photosynthesis, builds those sugars, gives them to the nodules for those bacteria in exchange for nitrogen, right? Why is this so important? What's this doing for our crop systems? Well, every day we breathe in and breathe out, 78% of that is nitrogen gas. Now, I didn't just use that, and corn plants can't use that, but there's some microbes that are pretty effective taking that nitrogen out of the air and giving it to the plant in a usable form. And so pretty straightforward, nitrogen fixing bacteria increase plant available nitrogen. Dr. Beal alluded to what's one of the challenges of residue: a lot of carbon, a lot of nitrogen immobilization, right? So maybe nitrogen fixing bacteria is an opportunity to provide another source of nitrogen in the root zone under these higher residue scenarios that might be tying or keeping some of our nitrogen from the soil mineral pools unavailable. Then you have phosphorus solubilizing bacteria. And what these do is they increase the availability of mineral phosphorus, right? So we know that there's a ton of phosphorus in our soils, but the plant can't use it because it's tied to soil cations and it's not able to be taken up in that form. So what these bacteria do is they secrete organic acids that then release phosphorus from those cations, and now it's plant available. So nitrogen with the nitrogen fixing bacteria, phosphorus, the mineral pool is the solubilizing bacteria, and then the mycorrhizal fungi is the third group of beneficial microbes. These, in essence, extend the root system. They're natural to plant systems. They're symbionts with plants in our cropping and different forest systems. And what they do is they grow and they help that plant explore the soil profile, right? So largely in search of water, as well as immobile nutrients like phosphorus. You're going to start to see a trend here. A lot of these biologicals are related to nutrient availability and use. And that's exactly where the benefits are going to come in for these cropping systems. So those are the three most common beneficial microbes. Now, you'll notice on there, there's a category I might be missing, and that's this bacillus soil amendments aspect space, because we're going to talk about that in a little bit. That's, I think, the opportunity and where this market is going next. But that's the three most common today living beneficial microbes. Now we're going to get into these biostimulants, starting with enzymes, particularly the phosphatases. And what enzymes do is they're very specific. So enzymes, in the case of soils, degrade organic matter, but they attack very specific bonds. So a phosphatase is very specific at releasing organic phosphorus from our residues. Now, what's really interesting here, right? These enzymes, these phosphatases, they increase organic phosphorus. Now, these phosphorus solubilizing bacteria up here, they release mineral phosphorus. So I have two different biologicals releasing two different pools of phosphorus, an immobile nutrient that can often be limiting crop yield. And now we're starting to get some synergies, providing nutrition, especially if those root systems are getting smaller and they can't find that immobile nutrient as easy as they used to with the bigger root systems at lower populations. Now we're seeing the role of biologicals to benefit nutrient availability for our cropping systems. One of the cool things about this space with the enzymes is phosphatases is, I think, what opened the gate to these types of products on the market. But just like the phosphatases, there are sulfatases. So let's release sulfur from our organic matter. There are nitrogen cycling enzymes that release nitrogen from our organic matter. And guess what? There's carbon enzymes, cellulases, that go out and glucosidases. You've seen this in the soil health perspective. They're using glucosidases as a soil health measurement. It's because it's cycling carbon, cycling residue. And so we're going to start seeing a shift as well to enzyme products designed to target residue decomposition. Now that's the pure enzyme, but there's microbes that produce those enzymes as well. And those are going to help us degrade the residues. And this is some of, I think, the discussions that you've been having throughout the day and what we're talking about with different biological products targeting residues. Then you have humic fulvic acids. So these can chelate soil cations as well as feed microbes. These have been around for a while. There's a lot of different kinds. There's liquids, there's dries. Some are applied a couple 100 pounds to the acre as soil amendment, but some are used to stimulate the crop. So there's a lot, we could spend a whole webinar on this category. And they also kind of help open the door to this market space. And then the last two, the marine extracts and the sugars, I kind of grouped together because they're doing similar components when we use them in our system. So when we soil apply these, they stimulate the microbes in the roots, right? It's free sugar, free amino acids, a little bit of plant hormone in there, it's stimulating the root zone. Or a foliar application is drought mitigation. So now you can see here's a play that's not necessarily the nutrient aspect. But when we go through this, these are the top 7 that we kind of have been seeing lately. And when we summarize the biologicals, we've done a lot of studies and we say that we see that they can be effective at increasing grain yield. However, that efficacy depends on which type of product you're using, right? So is it the end fixer or the phosphorus solubilizer? And to get the optimized benefit, you really have to understand how that product works and where it fits for your system. Strong believer in the biological space, but it's making sure you choose the right biological for the task that you're wishing to achieve. And so that's kind of our perspective on the biologicals and the categories. And then as Dr. Bilo mentioned, how do we use biologicals? Well, here's the most common free rides, right? Some visual examples of that. But we really like the idea of the crop residue perspective, because there's a lot of good nutrition in that residue. If we can get the value of it, then we're going to be providing new nutrition for the next year's crop, minimizing some of that issues with nitrogen mobilization, planter difficulties going through the next spring. And so I'm going to walk through a case study where we mitigated the continuous corn yield penalties. Dr. Bilo showed you that penalty does not go away with time. And we're looking at combinations of mechanical and biological applications as a synergy effect. Ultimately, the question is, can we manage the crop residue to mitigate the continuous corn yield penalty? Now, that was our approach, and what we're looking at is continuous corn. We're at 15 or more years on the study, but think about just high yields, right? 300 plus bushels is a lot of residues, Dr. Bilo mentioned. So we also have to just think about managing high residue scenarios in general. So we did a study over the course of a 3-year period, 2019 to 2021, and Dr. Bilo already showed you, we got the sizing, the mechanical, expose that residue so the microbes can then be active on that more surface area for them to do their job. Then we're going to give them a little ammonium sulfate, right? And so I got the metric on here, but they were looking at 48 pounds of sulfur, 42 pounds of nitrogen as ammonium sulfate, giving a little bit of sulfur, a little bit of nitrogen with that fresh carbon. Man, now the microbes have all the nutrients they need to start degrading the residue, just enough to get them rolling. And then we're going to look at either a microbial fermentation product, a humic acid, or a living microbial blend on top of that, all designed to enhance residue decomposition and improve our yields under a high residue continuous corn scenario. And so the first thing that I have right here, so our corn soybean rotation, right, the standard Midwest approach, we had an average corn yield of 201 bushels per acre. This is actually the 2-year results. I've got 2020 there, but it's the 2-year results summarized here. And this year, after I think this was year 19 of continuous corn, 48 bushels was the yield penalty, right? It keeps going up. Now, when we size those residues, that penalty was 36 bushels. We had a decrease in the penalty of 12 bushels, meaning we're improving the yields on a continuous corn scenario, right? Starting to get closer to that corn soy rotation standard, and you do the economics, getting much more ROI parallel perspective. When we added the ammonium sulfate, right, we gained another bushel in this case. It's adding on top of that sizing residues. But what was really exciting for us across the 2 years, very consistently, when we then added a microbial biological, a living blend of microbial species on top of the size residues with a little nitrogen sulfur, we got the best response. Another 11 bushel decrease in the penalty, meaning 11 bushels added on the yield side, ultimately meaning we cut the continuous corn yield penalty in half. And so now we're much closer to that corn soy rotation. We look at the high corn markets. Yes, this 201 is still the highest yield, but if you can do this value years over time, then the ROI over time has a benefit to itself. And one just note, when we put the microbial biological directly by itself, it's only a 4 bushel advantage compared to these other responses. So it's the synergies. It's putting the products into a system with the fresh residues, with the exposed surface area, little nitrogen sulfur for them to start acting and getting into that residue, degrading it. And then you got to give the microbes right there, put them right on top of the residues. They can start feeding away on it, breaking it down, and we get a continued synergy response. So when we think about residue from a biological perspective of management, it's additive increase in grain yields with the systems approach. That's the key that we saw. Any one practice alone got us a little bit of the way. When we added the practices together, it was the next step for progressive management of these residue scenarios. And so when we talk about biological summary, there are certain biologicals similar in type as in the category, but each product is unique. From the nitrogen fixation, there's different ways that microbes fix nitrogen with the plant, but they're all end fixers. So you really need to understand, what's the product of interest, to optimize its performance across different environments and different systems. And so when we're going to kind of summarize it and just say, ultimately know your starting point and have a goal with what you wish to achieve. And what we mean by that is, don't just let a product, come across the table and force it into a system. Look at the product, evaluate your system, and decide, hey, this is the biological I need to accomplish this task, or it's not. We're going to find a different product to get the task that you want done. That's the best opportunity to get success out of biological applications, especially when we're thinking about putting them into a residue management scenario. Huge thank you. We're going to end with a quick thank you to our team. Got, of course, Dr. Bilo and myself are here today, but all the research we showed and all the background work that went into getting the data and our conclusions to the slide comes to this great team here is our 2022 team. I don't know if you want to say anything, Dr. Bilo, on behalf, but we got 2 PhD students, 2 master's students, and a bunch of visiting scholars. It takes a small army to get all that research done. And then a special thanks to everyone attending. I think we'll take some questions, some Q&A at this time.
Yeah, can I jump in here, Paul, with a couple of things just for because I mean, obviously I think this is fantastic work.
Yeah.
And we, Dr. Bilo, Dr. Sybil, just incredibly way to frame this up. And we have seen many of the same things as as part of the product development team under the Streamline leadership. And this whole thing of the surface area to break down residue is a huge deal. And I think we agree that when you create more surface area through chopping, these bacillus and fungi families that are in residue release do work better. And that's and then when we added the fulvic acid, we had another response. And then the big thing that I want, again, just so these folks on the phone call can hear this, the big challenge when you don't have a chopping effect is breaking through the cuticle and getting the microbes in a place where they can feed on the pith. And that was a real challenge we put to Brian Hashmeyer and the chemistry team and Joe Ganowski and a bunch of other scientists we work with. And the idea that came out was to use a really, really rough and tumble APG, which is a non-ionic surfactant system that is specifically cuts the cuticle of the corn stover. And that has, when we've looked at that versus without that carrier system, we've seen a really, really different response. And again, just for the benefit of the team here, that is the reason we're seeing the performance of residue release is this fulvic acid and carrier system with the APG. And APG is actually a long chain carbon itself. It's a spreader sticker, and it also helps develop that. So that use of that carrier system has been a big deal for us. And also then the layering of fungi with live microbes with fulvic in a carrier that will be shelf stable is kind of where we got excited over the last 24 months in product development. And I just if you want to react to that or anybody else asks a question, but given that we're in the heat of battle with residue release, I wanted to put that out there, Paul. So
I appreciate that, Rob. And I was in as at a research farm in Springfield, Illinois yesterday, and in blocks of replicated plots, same hybrid. Residue release was used last fall, and the corn where there was no residue release applied was almost fully senesced versus the applied. It was amazing to see 2/3 of the plant where residue release was applied last fall was still green, still photosynthesizing, where just right across where they didn't completely senesced. So obvious things showing up in the field that we're seeing today. I was talking with Kip up in South Dakota yesterday, and they applied residue release 2 weeks ago on wheat stubble. And he said you can see right to the line. He could already the wheat stubble's standing, but it's got a different, darker color. So lots of activity. seeing good results there. So we do have a few questions, and if you
Yeah.
have any questions for myself, for Rob, for Dr. Belo, put them on the chat and we'll ask them. We do have one here. Are PGRs EPA regulated?
Hey, so Paul, I'm going to let Dr. Sybil ask that question. He's an expert. But
Yep.
before I get to that, I want to chime back into what Rob and you alluded to. So the surfactant, that comes with the residue release and getting it on that cuticle and keeping it alive, that's the key to the whole thing.
Yeah.
The product that we showed you was it was not a Streamline product or a Meristem product. I want to say it's a first generation of microbial mixtures, and it was not necessarily optimized for the breakdown of residue. So I think with residue release, that's a big step in the right direction. I kind of wish our work had been done using that. So it was not that product, but it's the concept of the value of residue and how it has to be managed. And I want to reiterate, a lot of things that our growers are doing are generating a lot of residue, whether it's high yields, cover crops, conservation tillage, continuous corn. I mean, this is something that there's some real value there that, and I getting that process started. So the surfactant is huge. Now back to the question about EPA regulation. I'll let Dr. Sybil answer that.
Well, I'll sidestep just to mention residue degradation microbes was not on my list of 7 because I think, as Dr. Belo mentioned, it's definitely going to be on that list in the next coming years on the value of residue, the minimal tillage comparisons, cover crops. So the space and the opportunity in the residue management, I think, is just going to continue to grow, and there's going to be continued leaps and bounds as we better understand how to capitalize that value. As far as PGRs EPA regulated, yes, they go through the same labeling process as herbicides, fungicides, pesticides. They're expensive, very rigorous. So I will say, if you have a PGR that's labeled, the groundwork and footwork's been done to get that label EPA approved. Beneficial microbiostimulants is currently in process, but there is no exact strict EPA regulation guideline on that to date.
Yeah.
But that process is en route as well.
This Panetta bill, I mean, maybe I can talk to you offline, but I want to make another note to the team here. We have, I don't think any team is for more regulation, but I want you guys to all take a special look at the tech sheets Paul and the Streamline team have done. We list everything that's in the products specifically without having to find and look for it. And there has to be more transparency. And the issue is, and correct me if you don't agree, in a lot of these beneficial microbes, it's hard to have intellectual property around them. It comes down to fermentation quality and the phenotyping and genotyping, people like University of Illinois and Rutgers and other people, and then getting them to be alive and on target. That's why Tune Up Plus and Residue Release, and now the Enzyme product that we're bringing into the zinc, we'll talk about later. I'm really excited about the enzyme space, but for durability and formulation. But back to this point on this space, be assured as a Streamline representative that you're one of the only companies that will actually tell a farmer exactly what's in these products, because we don't have any fear of market degradation. We're going to do this. We're going to do it right. And we'll keep getting better because it's going to be a journey. I love that journey slide. But there is a lot of confusion and a lot of folks that will not tell you what's in their mixture because they know deep down they can't protect it with IP. I understand that business issue, but you are in a very unique position with the tech sheets and the labeling and the transparency that you have at Streamline. If you disagree or you look at these labels, you don't know what's in them. It's really confusing. Maybe you see something different, Dr. Sybil, when you look across these labels of products. It's a real crazy deal.
I got a label the other day that living microbial colonies. When I asked about which colonies, I haven't gotten a reply back yet. So, microbes that have been selected are, no secret. There's a lot of common ones, like you mentioned, where companies differentiate themselves is the formulation, how they're getting it, delivery system. With key cast of characters, are largely, there's good microbes that are really good at doing that job. Common list of bacillus and some fungi, but it's all about the formulation and things that differs largely on the other side of things.
Sorry, I'll shut up, Paul. I just got excited with the presentation.
No, I was actually in a laboratory yesterday that we have at our resource that reverse engineers some of those products, and what they showed me yesterday just supports that there are some products out on the market today that aren't what they claim. So I do have one question. I don't see any more coming in on the chat. So if you've got one, go ahead and pose your question. But I was asked yesterday, if we're managing residue in the field and a lot of diseases that are showing up in corn, whether it be tar spot or white mold in beans or some of these, if we're managing the residue, could you build a hypothesis that you could see decreased disease pressure? Are you guys studying this at all, Dr. Sybil, maybe?
So are we studying that question specifically? No, but the logic is right there, right? So more residues, more inoculum, more areas for those diseases to overwinter and be there for the next year. Anything we can do to maybe break down that residue or manage that, it's going to reduce the inoculum level and should, in theory, reduce the disease pressure, at least the starting disease pressure each season.
Yeah, and Paul, I think the same thing is true for insect overwintering or, slugs, voles, just less cover, right?
Right.
Yeah. One of the things I think we have seen too is if you rotate the genetics, if you're in a continuous corn scenario, that does tend to help. Don't put the same hybrid 3 years in a row. If you put the same hybrid into the same residue, it's got the same susceptibility. So if you change your trait package or your hybrid a little bit year to year, that has a little bit different susceptibility to disease, then there's a less chance that what inoculum is there is it's like giving it the same host right away. Stack the deck for the microbes, let's stack it against them. One thing to consider in a continuous, even if it's a 2-year, corn soy rotation, seeing more of that. Think about that second year corn, changing the hybrid up from what you may have done the year before.
So we didn't get a chance to talk about it much, but we also think that this whole issue of cover crops and managing the cover crops in season is a huge impact for these types of products. I know Dr. Sybil and I are going to try and put some trials out next year, maybe including residue release. But one of the problems with cover crops, as anybody knows, is they get ahead of you. Then they get too much residue. It starts to immobilize. We don't get the value of them in season, and so we see these types of technologies as a perfect scenario for managing the residual cover crops and helping us with double crops. Managing the wheat straw before we're going to try and double crop a soybean. These are other huge opportunities that require residue and enhanced residue degradation that we didn't even talk about here today.
We've got one other question that's come in, and how do the products need to be handled? I think the question is around, do we need to protect them from freezing, from extreme heat?
So I can give a general view, and then Rob has specifics.
And then maybe Dr. Sybil can.
Yeah. In general, living microbes are just that, alive. And so, yes, extreme freezing, extreme heat, they can degrade. Many of the bacillus are in the spores, which are pretty resilient, but they're not bulletproof. So one of the examples I use, if you have a living one at planting, life happens, the planter breaks down, right? And so you're on the ground for 3 hours fixing the planter, you get it running again, but you put the jug on the trailer in the sun for 3 hours. Now that sun exposure UV for 3 hours in a hot trailer, probably not the best. So always have to be now mindful with these specialty products, how we're using them. One of the things that's interesting in the enzyme space, these microbes produce enzymes to then degrade residue or release nutrition. The enzymes themselves are not alive. So that's going to change things as well. As it's kind of like skipping the middleman. So the pure enzymes is one of those that it's not living, so you don't necessarily have to keep it alive. You got a little more leeway on that.
this is a great conversation. Generally, it's not good to freeze or get anything too hot or too cold. I mean, just as a general rule across all kinds of formulations, biological or synthetic, just as a general rule. On the biological space, there's a lot of companies that we're looking into with Paul on the having some sporulation technology that claims, and I'd love your claim to have hardier and keep the spore formers in their spore form longer. And that's what we've tried to do in the with Brian Hashmeyer and Lucas and the team that formulated it with Art, is trying to create a very, very, very stable pH buffer and a food source and a suspension mechanism to hold the residue release microbes in spore form in a suspension at a constant pH. Okay. Now, sunlight, I don't want any of these things out in the sunlight too long. One of the reasons we think residue release works better with this heavy 35% of the volume surfactant, and that's the patent that residue release is actually licensing. When it gets in out of the sun and gets into the cuticle, we think that's having something to do with our survivability. We know we're getting increased populations. So generally, I don't want anything too hot or too cold. I don't want it to be in the sunlight too long. That's in the liquid environment. In the dry environment, you'll notice on the Tune Up Plus product, and it's not going to be in a translucent jug for a reason. It's going to be opaque. And we also have the biocapsule with the Tune Up Plus, so we can keep them in actually a very certain stable as possible condition in terms of moisture or change of temperature. Because what we're trying to do in the dry is create a dry flowable version of the spores with the right specific gravity to mix thoroughly and coat evenly as a planter box treatment along with the talc graphite. So those spores and then that we have in one is actually an M-troph that we licensed from New Leaf, and one is a consortium that we've built with DPH. Have very, very good survivability when they're held separate from talc, separate from zinc. Zinc is hard on all these things. I know I'm going beyond, but those can handle a lot of hot, cold, but still rather have them out of the sun.
Yeah.
It should be pretty decent, yeah. Irrigate will be tremendous. I mean, we just been
But he's
having
on.
normal every month and getting by.
Yeah, I
but,
think Jeff's on the phone.
Yeah, I
with someone there.
expect
Hey,
a above
so,
average crop.
Dr. Sybil, Dr. Belo, thank you very much for your time this morning. Very informative. Every time I listen to you guys speak, I learn something new. So, Mr. McClellan, thank you for joining us as well this morning.
Yeah, it's
This
prevalent.
is pre-recorded. This is recorded. So you
Yes.
will
One
be
of the sides
able
of this
to,
kind of kept it.
come back and watch this again.
Tolerate it
I'll send
anyhow,
out a
so,
note to all
but,
our dealers on where to
yeah.
find it. And appreciate everyone that
Yeah,
joined.
it's a tough disease though. I mean, I've
To
seen
learn
guys
about
spray it.
biologicals. We have residue release ready to
No.
ship.
No.
Fall in the corn country is the best time to apply after harvest. So let us know if you need some, and we'll get it coming your way.
Thanks, guys.
Thank you very much, everybody.
Yep. Bye-bye. Thank you, Dr. Belo, Dr. Sybil. My apologies for the typo.
Hopefully that was good enough. Seemed like we rushed through a lot of stuff, but man,
No.
there's a lot of stuff here.
No, and you're renowned, not renounced.
All right, thank you. That's no
Yeah,
problem.
yeah, I was actually in the process of
Bye-bye.
signing it as you called, so I got in front of me right now.